Hello, Steve Swayze here for DragonEye GPS Tracking. In this video, I'll be discussing how GPS tracking works. Not in a highly technical manner where I'll be diving down into details of subjects like wide area networks, surface movement guidance and control systems, or long range radio frequency, but at an overview level in an effort to help decision makers and practitioners understand system basics so they can make intelligent decisions when selecting a GPS tracking system. In effect, ShareGeo is interested in helping communities and consumers make an apples to apples comparison so their purchasing dollars are efficiently spent to acquire the system that is the correct fit for their needs. In that regard, we are trying to overcome the barrier that is the tendency of GPS tracking companies to be tight-lipped about their product lines and various hidden costs. There are three basic components to any GPS tracking system. The first one we'll look at is hardware. The cost, accuracy, and data transmission rates of GPS tracking hardware can be highly variable. To give structure to this topic and the other two elements of this discussion, I'll be using 5 categories of GPS tracking to highlight differences and similarities. The first of the 5 categories is aviation. In days gone by, aircraft were seen on radar when an electronic beacon or transponder in the airframe would send out a signal which would highlight its location on a controller's scope. This signal would provide information about the aircraft's speed and altitude and other information as measured off of equipment on board the aircraft. Driven by the need for better aircraft visibility in areas without radar coverage, oceanic crossings would be an example. Increasing density of aircraft in the skies where radar coverage exists, and aircraft ground movement and control issues in reduced visibility conditions. Since the early 2000s, the aviation industry has been moving towards using GPS tracking to replace the traditional transponder. The equipment supporting this type of GPS tracking can cost tens of thousands of dollars to install and maintain. The location signal is typically sent sub-second and will be more accurate than the aircraft's shadow, which for some larger airframes can be hundreds of feet. The second category primarily includes advanced public works and utility equipment. These vehicles can be equipped with either aircraft transponder type systems or equipment specifically designed for sending near continuous and highly accurate location and vehicle status information. Driving this high throughput scenario are safety issues and return on investment considerations. For example, the dispense rate of salt and sand out of a spreader on a snowplow can be monitored and adjusted as a function of the data transmission. Data coming in from other vehicle functions monitored by the vehicle's controller area network, CAN bus, such as plow height, lights on off, wipers on off, can also be used to update route driving conditions to a control center as frequently as every quarter mile. Location accuracy from this type of equipment will typically be state-of-the-art, currently sub-meter, and be sent in across a dedicated radio or cellular system. Expect this type of hardware to be in the range of $2,000 for equipment and install. The number of vendors able to provide this type of equipment is very limited. Before leaving this category, it is important to note that these type of installs sometimes also have the ability to deliver back to the driver information about the location of other assets. In the military, this is known as Blue Force Tracker. In the civilian emergency services sector, this is known as a Common Operating Picture, or COP. The total system architecture required to gather location information on numerous assets and rebroadcast in real time is significant and should not be confused with concepts which track multiple assets and then aggregate that information at one or two locations in a command and control approach. The third category uses either a unit that is plugged directly into the vehicle's onboard diagnostics data port, hardwired into a vehicle's electrical system, or comes in some form of a rechargeable personal GPS beacon, and is commonly referred to as SST, or Simple Stupid Tracking. In this realm, the quality of the location information available is driven by the quality of the installed GPS chip and the monthly communications plan purchased with the hardware. This field is flooded with vendors, and the differences in hardware costs can normally be traced back directly to the quality of the GPS chip. Location accuracy will typically be around 40 feet, with an update rate of 1 minute or higher, depending on the associated communication plan. These systems are usually found employed in situations where there is a need for location information that is general in vicinity, and the communications flow is one way with no in-cab location awareness of other assets in the system. Category 4 is Internet of Things hardware. Associated equipment is battery powered because the host is normally unpowered, and the need for tracking might be limited to finding stolen or misplaced equipment. These units operate on a cellular frequency band that has been set aside for machine communication. This frequency facilitates low battery use and infrequent communication. Given this concept is intended to be used in volume, monitoring crates of lettuce during shipment, as an example, these units will be toward the bottom of the price range for equipment with tracking capabilities, but also have location accuracy that is the poorest across the spectrum on GPS tracking equipment. Taken together with a transmission send that can be as infrequent as 1 week, there are very few scenarios where their use in active GPS tracking makes sense. The last category is the one which is most surprising to many people: smartphone location reporting. Although much has been made in the press of cell tower triangulation where bad people have been tracked doing bad things, reality is pretty much every mobile device manufactured since about 2009 has a built-in GPS chip as a part of its architecture. The accuracy of these chips can be extremely good. Studies conducted by the FAA in 2017 determined that high-quality GPS aviation systems were accurate to less than 6.2 feet, while smartphones compared favorably at under 16 feet. As of 2019, some manufacturers have been working to include GPS chips which can go down to near survey quality in centimeters. Thus, while buying a smartphone for the sole purposes of GPS tracking doesn't make financial sense, as an additional use, particularly if an organization or individual already has in place a volume communication plan, a smartphone can offer substantial GPS tracking capability at no additional cost. Okay, let's now consider the communications part of GPS tracking. Wow, look at that! The aviation GPS tracking signal cost is zero, a price which, as shown, is dishonest. While the signal is, quote, free, unquote, through various aviation taxes and government funding of the FAA, the substantial bill is getting paid. In order for the high volume telemetry collection coming in off of the second category of equipment to be effectively delivered, some type of contract service will be in place with a cellular provider or a vendor providing a dedicated private radio network, such as at an airport. In both cases, the per unit charge for the communications link will be something under $50, typically around $35 per month. Simple, stupid tracking vendors often forget to mention the communication charge until after the hardware sale. Well, to use this piece of equipment, you'll need to find your own communication plan, or we will sell you our XYZ plan. Look for this charge to be driven almost exclusively by your need for data send frequency and corresponding accuracy of location reporting, with a transmission every 10 minutes being about one half of what their best possible reporting rate of every minute would cost. This puts you in the range of $25 to $45 per month per asset being tracked. LTE-M, or Long-Term Evolution Machine, is the cheapest communication channel by far due to its infrequent use as previously explained, and the dedicated nature of the frequency. But as in all things, you get what you pay for. Effectively, a very limited use case for location reporting. Expect $10 and under, with about $3 per month being the norm. Cellular. There are a variety of plans with various bells and whistles which seem to be always changing. Suffice it to say, this one is a moving target. If you already have a plan in place, your cost is zero to add smartphone tracking. The last thought on this one is how communication channels used by GPS tracking compare without consideration of price. Consider this slide. Radio. Dedicated communication pipe supporting high data throughput, reliability, and security. Cellular. Most common AVL connection, or automatic vehicle location connection, able to go sub 5 seconds with the right equipment. One or both of these approaches will be used in the vast majority of cases. However, there are some less used communication channels, SATCOM or satellite communication, used in remote areas where tracking is needed, typically most expensive system and used infrequently. Think north of the Arctic Circle airport, where an airport manager is trying to keep track of his assets. Wi-Fi, limited range, limited availability, fringe approach for pretty much anything other than indoor tracking. LoRa, or long range, low rate throughput, growing technology for the Internet of Things. Alright, the last major component to the generic GPS tracking system is the data center. Essentially, the data center is the software which collects, routes, and converts incoming GPS tracks and associated data into signals which can then be ingested into other systems so they are delivered to humans in a meaningful way. A data center can be exactly that, hosted in a commercial data center as a way to guarantee access to power and efficient connection to the communications channel. This arrangement is typically associated with approaches which are sold as software as a service. When there is a need for increased security or control, the second approach will normally be used, that of a data center running on a dedicated on-site server. In either case, output from the data center will be delivered in a variety of ways. In the aviation world, aircraft movement on the ground and in immediate vicinity of an airfield will be shown on a computer screen and digitally recorded for playback. High-end telemetry information can end up as a CSV spreadsheet, situational display, or both. Signals in the simple, stupid tracking category are also normally delivered as a CSV file or on a very basic online map such as Google Maps. Internet of Things data is commonly delivered as text messaging or a website focused on equipment status. Finally, smartphone tracking has the most expansive range of delivery through various web apps. So, even though there are three components to capturing and processing GPS location data, the critical point in making all this effort worthwhile is the viewer. It is the means by which all parts of the effort are pulled together. In this regard, the evolution over time has been significant. When GPS tracking first emerged in the fleet management world during the late 1990s, tracking was principally a historic review based on CSV track analysis. Driven by the emergency services sector's need for operational clarity, the idea followed in the early 2000s that location data could be pulled into computer-aided dispatch systems in a map form as a way to facilitate awareness and response. Many civilian sector vendors responded to this development by starting to offer simple online mapping systems to augment their previous textual-only focused approaches. The current revolution in the technology world is to make web-hosted maps the canvas upon which the data is laid and analyzed. This development will be impactful on the GPS tracking community going forward. The map, not the spreadsheet, will be the core of future developments. With this thought in mind, a very important point to consider when building a GPS tracking system is the data viewer. Some points you may wish to consider are capabilities. Is it a one-dimensional Google-type map add-on, or is it a dedicated viewer with analytic capability? Install flexibility. Is it software as a service, local install, or can it be either? Adaptability. Can it be customized and adapted to evolving needs going forward? Or is it a one-size-fits-all approach? Channeling. Does a vendor's hardware lock you into a viewer with limited capability? Operational control. Is the viewer functionally command and control only, or can it support a common operating picture approach? Data center feeds. Is the viewer able to handle feeds from multiple data centers, or can it only ingest one or two? That concludes this presentation. If you have any comments or questions, please feel free to contact me, Steve Swayze, at sdswazee@sharegeo.org. Thank you for your attention.